Coulombs' law is an equation used to tell us how strong the electric force is between two charges. This equation may look a bit complicated at first, but it is actually quite straightforward. Let's break it down. First, F is the result of the equation, and it states how much the charges push or pull on each other. Q1 and Q2 are the sizes of the two charges measured in coulombs. The bigger the charge, the bigger the force. Also, if Q1 and Q2 are the same polarity, they push each other apart, but if they're opposite polarities, they are pulled together. R is the distance between them, and since it's squared, a doubling of the distance between two charges reduces the force to a quarter. Finally, the 1 over 4 pi epsilon naught times epsilon r, which is sometimes simplified into a single constant called K, or Coulomb's constant. Epsilon naught is called the permittivity of free space, and it is a constant that never changes. It tells us how electric fields behave in a vacuum. Epsilon r tells us how much the surrounding material affects the force. In a vacuum, epsilon r is 1, but in other materials, it can be higher, which weakens the force between charges. Overall, the entire fraction of 1 over 4 pi epsilon naught epsilon r tells us how easily electric fields can form in a given space. Coulomb's law is a powerful formula that explains why static causes things to stick to your clothes, why electrons orbit a nucleus, and why we need insulating wires in electronics.